Welcome back to the YouTube tutorial on the deep learning course. So in this section, we try to see about the convolutional neural network or CNN, which is like the one of the most popular topics in deep learning algorithm. Let's try to see about the concept of convolutional neural network or CNN. So this convolutional neural network, which is also known as convolutional network or combinates, which is like type of deep learning algorithm, mainly that try to design for the object recognition, like for image classification, for image detection and segmentation purpose. So originally, actually, this one will be designed for related to image data sets, but still actually it can be possible to use for a type of time series data set. So we'll see this one in the next slide. So this type of CNN or CNN, which is like a type of variety of practical scenarios, which is like used for different applications, like for in the autonomous vehicles development, for security camera systems like videos and audios or images from the security cameras, and also it will be help in the different applications. So this convolutional network actually that's just like help us to use for a data set related to image and video processing tasks, which is like becoming very popular and most important in recent times. The difference from feed-forward neural network will be actually this one is not scale up to image and video processing tasks. So that's just like artificial neural network, maybe most commonly that is used for like type of time series data, and now CNN has become more popular in the image and video processing. For instance, this is an example that showed that the classification, localization, detection, and segmentation for CNN. So, for instance, the first one is object classification. The task that try to identify the pictures is whether it's a dog or the other animals, for instance. Thus, we call it classification. So we can give like different data set that have different animals. So the objective of CNN maybe just like to classify the image. So when you give some image, that helps us to classify whether that one is a dog, whether it's like a cat or a tiger, like this one. The second one is share that object localization. So just like try to localize only the objects. So just like ignore this one, the grass, but only try to localize the images. That is just image or object localization. So sometimes maybe in the crowded areas, if we want to just like localize some specific objects, this CNN may be just like the one type of algorithm to localize objects. And also this one is object detection. This object detection, it just involves localization of multiple objects. So this one is actually, for instance, this one is have a two dogs. So just like when you say that detection, just detect one dog here, also detect another dog. So just like cannot be possible to detect the whole in the one box here. So instead of that one, just like separately detecting every object or every dogs from that one, that we call it object detection. Actually, this is more related to like objects localizations, but that is the key. Another one is object segmentation, which is like involve the class label as well as an outline of the object in interest. So just like for instance from this one, it's only just segment only the objects like this one. So you see the background will be different, but in this case, so just like only segmented this part of the object. That's just some of the application of CNN is like this one. So the importance of CNN, especially when you compare with like some of the traditional machine learning algorithms, is like the ability to autonomously or automatically extract features from the image or from the video. So no need of this manual feature extraction from the data set. So instead of that one, the algorithm by itself, it will be extract like features from the data set. That's just the one important feature of CNN. The other one is CNN. Like in addition with the image classification tasks, CNN are which is like type of algorithm which is applied to range of other domains. Like for instance, will be applied in the natural language processing for like handwritten digital recognition, voice recognition, and other like language translation. This will be an application in natural language processing for time series analysis. So time series data, which means like the data which is in terms of sequential data, not image based data, like the data within CSV format or Excel format or text like that one. And the speech recognition. This is also some of the application of CNN that will be implemented. So the reason why CNN is for image is because some patterns are much smaller than the whole image. So just this CNN is just try to help us to capture even that small part of the image. So this one is, for instance, the image. So a neuron does not have to see the whole image to discover the patterns like this one. If we when we give like these images, so connecting to small region with less parameters or like this one in CNN actually like by splitting every part of the images that helps us to understand in detail about the images. That is just the one function of CNN which is different from the other one. So from this one, for instance, this part will be just detected separately, the other part of the body is separately detected, and then we can combine together. Finally it gives us a full image about the image or the objects. So this is just an example. For instance, the same pattern appears in different regions like this one and this one with like different bird types. So this one is like the back detector, it's detect the back of this bird, and also this one is a middle back detector, just like in the middle of this one. So do almost the same things, but they can use the same set of parameter for doing this or detection. This is also another example that shows that when CNN is for image, for instance, in CNN, that is the reason. This is, for instance, the digit recognition. So this is number 9. This is given for the model. So the model can try to capture in detail about this one. So in order to understand about these images, this image will be split into different parts. You see here, for instance, this part of the image is like this one. And then this part, the curve will be like this one, and then the other one is maybe this last side will be just given like this one, and there is a curve like here, you see this one, and finally this one. So like this one will be splitted, and this one is will be splitted, and this one is splitted into 3 parts. So this one, you see, it gives 0, and this one is give like this one, and this one is like this one, and finally will be gives like the combination will be 9. So that is why CNN is different from the other algorithms. It tries to just like capture every smaller part of the objects, and then automatically just extract these features from the image. So just like instead of like maybe if just automatically capture the whole images, maybe they miss some important information, but just like when we just try to detect every part of the images, that helps to clearly understand about their character or about the object. So loopy circle patterns will be just like separated, and then this part, the vertical lines as the one, and then this one. Then by using or by combining these 3 parts, finally it gives full information about whether this one is digit 9, digit 8, digit 7, and like that one, which is like the most important thing. The other one, the importance of CNN will be it's subsampling the pixels without changing the objects. For instance, in CNN, this one is the original bird. After applying subsampling, the object or the images become this one. So without change the original image, by only reducing the size of the images, that it can be possible to extract the image. So that is just the one way that reduces actually the processing time or also the memory by just like by sampling. So we can sample the pixel to make the image into smaller one. So without changing the original objects, we can just try to reduce the size, but still CNN can understand or extract every feature from the image. So let's see the architecture of the CNN. the typical CNN has 4 layers: input layer, convolutional layer, pooling layer, and fully connected layer. So basically, when you talk about CNN, these 4 layers are the most important part of this one. So just like we can, especially this one is for 2D and above that CNN parts. Uh, there is also actually 1D CNN. That's just maybe some layer is not important for 1D CNN, but this layer is especially for type of 2D CNN. That means if our data set is image-based data set, so we use like this type of layers in order to train the models. So let's see in detail about each type of or each layer of the CNN network. So this is the structure that shows that how the convolutional network or CNN. So the first one is the input layer. And here there is convolutional plus activation functions. For instance, ReLU is like the most common activation functions recently. And then pooling or subsampling. And again, we can add convolution. And again, we can add pooling. And then this one is, we call it fully connected layers, which is the last layer that performs the classification. So we'll see this one actually in detail about the structure. So this is the whole structure that shows that how the CNN will be looks like that one. So input layer, and then the combination of convolution and pooling layer, just like we can add maybe 1 layer, 2 layer, or 3 layer. It depends on that one. In the fully connected layers, actually, just we can try to make it flatten, and then we can apply it fully connected layers. Finally, we can apply the softmax activation function for classification or for detection, which is like the output layer for this one. So in general, we can split into 2 types. From this one, for convolutional and pooling layers, we call it like type of future engineering or future learning. So that's just the way of learning mechanisms. And finally, fully connected layer is a layer that helps for classification or for detection or for segmentation for that part. So when you see that, for instance, this is an image, an input image. So we try to detect these images, which is a koala here. Then we can apply convolution here, and we can apply max pooling. So max pooling is just only to reduce the size of the image like here. And then we can add convolution. So we can repeat many times for this one. So I'll show you actually this one where we can repeat this one. And again, we can add also max pooling. And then this one, the image will be just like flatten, which means the image is changed into the numbers. So flatten means like the image will be finally changed into a number based. And then we can just like enter into the fully connected or fit for our networks, and then classify like whether it's koala, whether it's cat, or whether it's dog, or any type of animal by using these images. That is just the whole structure of CNN. For instance, from this one also, an input image, and then a convolution means like that helps us to just extract every part of the image. For instance, here in the first convolution plus activation function, from this image only eye, nose, and ear will be extracted. So the first convolution will be just like try to extract the information separately. So the eye part, the nose part, the ear part, tail, leg, and every part will be just like separately detected. And then just apply the pooling. So that means when we apply pooling, you see the size will be reduced from this one and it becomes pooling. Again, we can add convolution. So when we add the second convolution, then just we can try to also detect the images by splitting into different parts. So in this case, in detail, just try to detect the koala's eye, nose, ear, and every part separately. But when it comes to here, the head part separately, and then the body part. So we need to split into 2 parts. Head part is separately, and the body part will be separately. And then again, we can apply pooling, just reduce the size from this one. And then this will be flattened. So after flatten, actually, instead of the image, it will be changed into numbers. For instance, here 1 and 1, and fully connected layers. Then finally, whether this one is koala or not, like this, will be the process. So that is just a way of convolutional neural networks. So here is the input. For instance, this is like the one image, this one is input, and maybe this area will be input, and this part is this one, and this one will be here. So this is just different convolution will be just like extract some parts from the image and will be just like that helps to detail understanding for the models. And then fully connected layer, and then is it bird, is sunset, is dog, is cat, like the probability will be calculated, and then we can just get the output from this one. So let's see step by step about each layer of the CNN. So the first one actually input layer. So input layer is always like just like it accepts inputs from the dataset or data accepted the dataset. So for instance, the input image may be 28 by 28 pixel grayscale image. So this 28 by 28 is when we just like use image as a dataset, we need to get or we need to just arrange it, the head and the widest. That is 88 by 28. I mean 28 by 28 means like the widest and the head will be 28. So unlike the feed-forward neural networks, so we do not flatten the input to the 1D vector. So 1D vector means actually just like series one, but because of the image, it will be 2D. When they like the dimensional for the height and the width, so that's just 2D vectors. So input is presented to the network in 2D, which means 28, 20. So this is one, then this is another dimension. So this makes capturing spatial relationship, which makes easier for the models. But instead of 1D dataset, it's actually just like, for instance, when you say that 1D, the data will be just like series. So when you say that, for instance, 1D, this one is 1D, this one is 2 and 3, maybe just like only 1D type of data sets will be represented. So let's see, for instance, the second layer, which is we call it convolutional layers. Convolutional layer. So what is convolutional layer? This is the first layer in the process of extracting valuable feature from the image. So this type of layer is the most important part of the CNN that helps us to extract every detail about the image. So in these convolutional layers, several filters of the equal size are applied, and each filter is used to recognize a specific pattern from the image. Like, for instance, try to detect curve of the digits, the edges, the whole shape of the digits, and more. That helps us to just like capture important or a specific pattern from the image. So by using the split filters, that if filter will be just like try to filter or just like extract some parts from the image. So the other one, actually in CNN, every image is represented in the form of the matrix of the pixel values. For instance, this one is an example. This is the original image, real image of the digit 8, and then first image will be just represented in terms of matrix. So here represented in the form of the array or matrix, like this one. You see here, this one, this one, this one, this one, and this one. So for instance, you see that this one is no digit here, no digit here. That means this one, we can make it 0, 0. So because finally, actually, always we say that computer is already, I understand, in 0 and 1 format, right? So the image should be changed into 0 and 1 format. So when you change into 0 and 1 format, this one actually automatically changed by the algorithm. So only we need to give like this original image, and this extraction will be done by the algorithm. So in this case, you see, for instance, this one is already black. So this one is white space. So because of this one and this one is 0. Around here, actually, because this one have already touched these boxes, that means it is important spaces that to determine whether this digit is 8 or 1, right? So because of this one and this one, it become 1, 1. And this area, this one is white box, this one is white. So because this one is 0 and 0, because like this is just the model. So using like this one, the same space, actually, for instance, by using this one, the arrangement is like this one. So this, when you draw like this one, by just checking like this one, the model can understand that this digit will be number 8. So this one also 0, and also in the middle there is 0, like around here 1, 1. So this is just digit 8 is represented in the form of pixels of zeros and ones, just like this is representation. Then now the model will be just try to easily understand that whether this digit is number 8 and number 8. So every data or every image should be represented in terms of array and then in terms of pixels. That is why actually that the model will be represented in this case. So you see, like for instance, this is an image that we can see from this one, but the computer can try to see like this one. So always computer can understand images in terms of numbers, because that image will be changed into the pixels or in terms of matrices. So this may be an input array like image, which is height and width times c. This 3 means actually with different colors. So always the dimensionality of the images, like when you say that 2D, height, width, times 3 means actually this is because if like the image is a color image, like the color which is red, green, and blue, so that is so RGB, that's 3. If we make it like just this one is 1, that means or the image is only in with one color. And then when you change into this one into numbers, the number will be just like represented by using from this numbering system from 0 to 255. So this convolutional layer, we use small grids called filters or kernels that move over the image. So that image means actually when we have just images, in order to filter every part of the image, we use a filter or a kernel that move over the image. So each small grid is like a mini magnifying glasses that looks for specific patterns in the photo, like it checks lines, check curves, and shapes like this one. So when it moves across the photo, it creates a new grid that highlights where it's found this pattern will be happen. So the reason why we use different path filter will be because when one filter may be good at finding straight lines, the other filter may be better for finding curves, and the other may be better to find the circles. So because of that one, we can apply to different filters, and that filter helps us to just finding maybe straight lines, maybe curves, maybe just like circles, and the other the type of lines. So by using different filters, CNN can get a good idea of all the different patterns that make up the image, will be just like really in detail understand about the image. For instance, this one actually, which is like the similar with the previous one, the convolution will be just like we can apply some pattern, which is this one, and then smaller than the whole image, for instance, and then also there is pooling or subsampling. The pixel will not change the object, only just like the size. And also the same pattern appear in different regions within different convolutions. So the case will be just repeats so many times. So this is the first convolution. Second convolution, which is like we can repeat from this one, which is like the idea is like this. So mostly actually when you say convolutional layer, this is a two-dimensional image. So there is a depth and the widest, I mean height and the widest, and the 3, which is represent actually the image will be a color image. So and then we can apply different filters. For instance, this 5 by 5. So means 5 pixel, 5, 5. So like from this table, we can just 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 5 by 5 means, for instance, from this one, this is a original image. From this image, just like checking 5 by 5. So 5 to this way and 5 to this way first, and next also 5 to this from this one and 5 to this one. So just like every image will be just like checking by using this ways. That is, we call it the convolutional or convolutional layers, or by using the filters. So for instance, here if we had just like 6 5 by 5 filters, 5 5, this is original image, and then when just like checking from this box, like 1 2 3 4 5 to here, 1 2 3 4 5 to here, like this one, and again maybe 1 2 3 4 5, 1 2 3 5 5. So totally let's say like 6. Mine means 1 2 3 4 5 6. So we have just 6 different convolutions with by using 5 by 5 filter. So 5 by 5 filter means actually from the table, just like or from the matrix, 5 into row direction and 5 into the column direction. That's just we can use, or we can pick this one. So the file or it looks like this one. Totally we have 6 different convolutions just the size is actually, which is the same, 28 by 28, which is like indicates the height and the width. So we stack this up to get new image of size 28, 28, and then 6 is represent the number of convolutions. For instance, this one also an example. Let's consider this 32 by 32 grayscale image of the handwritten digits. Let's say this one, 32 by 32 handwritten digits. So the value in the matrix are given for illustration purpose. For instance, this one. So around this one, first actually we need to make it this one into the arrays. This one. So this area is 0, 0, 0, 0 means this white spaces. So around this one, this area should be 1, 1. So let's say for instance here, using 0 0.1, 0 0.2, 0 0.5, 0 0.6 to represent around these areas. Or you can simply also, you can use 0 and 1. So don't confuse about this one actually, the pixel representation using different values. Anyways, the value that different from 0 is like, in this case, have important to determine the digit. So deep learning algorithm can use this point, this point, this point, this point, and this point is the important points and places that to try to determine about the image. But this one, 0, 0 means actually this area is like not important for that one. That's just the first step. The number will be just like changed into in this ways. Let's see, for instance, this is also another example. This is like digit 9. So just when you represent into the array formats, you see here, let's say for instance, the white space is negative and the important spaces we just like, or the area around the digits will be 1. So just like -1 and 1. 0 and 1, the same, no problem. So just like the only thing is the model just like try to differentiate which area will be just the important area to determine the digits and which one is like not important. That's the only difference. So in this case, just like try to use -1 and 1. So this one, 1, 1, 1, 1, 1, 1, 1. The rest one is, this one is the whole -1, -1, -1, like that one. So here, a digit 1, you see like this one, 1, 1, 1, 1, 1, 1. This just like that one. And then we can apply a filter. So for this case, for instance, we can use 3 different filters. The one filter is just only filter the loopy areas, loopy patterns, which means only this rectangle or the circles, only this one. So when we apply different filters from the image, just like that filter will be just like focus one. The first filter will be only filter these parts. The second filter just filter only these parts. You see this one, straight line, vertical line filters. And the third one is this type of filters, which is diagonal line filter. That is why using different convolutional layers is like try to detect or capture most important parameter from the image. Then you see, like for instance here also how it just like the filters will be like this one. So from this one, loopy pattern detector will be just like when you detect this one from the whole image, this is 1 indicated one, this one is 9 will be detected. So like this. So from this one, loopy pattern, loop will be just like around in the bottom. So here, the position will be around here from the whole one. So still actually we need to detect the other part also. Now only just detect this one because it's loopy or circle pattern filter. And number 8, for instance, because number 8 have one loopy filter here and one loop here. So because of that one, 1 here, the rest will be just like that one. 96, this one maybe around here in the top, and 6 will be at the bottom like this one. So this is only for type of loopy pattern detectors that just try to detect for the image. So convolution will be just like applied by these ways. So in general, in convolution layers, it's composed of multiple filters or kernels. So we can apply just like, for instance, different filters for detecting different curves or diagonals or like loops. Filter for 2D images are also like 2D. So just like the filter, let's say, for instance, the filter should be like 5 by 5, 3 by 3, 2 by 2, like that one. So the filters also, it should be 2D. So suppose we have a 3 by 3 filters, so 9 values in total, then we can get like this one. So the values are randomly set from 0 and 1. That's like this one. So filters that try to move filter to right 1 pixel at a time and repeat this process. So will be just like move like in 3 by 3 filters on the top of left corner, that will be just like apply. So when at the top right corner, moves filter down 1 pixel and then repeat the process. For instance, let's show this one. You see the filter, for instance, if this one, if say that the 3 by 3 filters started from this one. So first check from this one, 1, 2, 3, 1, 2, 3. Again, 1, 2, 3, 1, 2, 3. And then every part of the pixels will be just like check by using 3 by 3. So the procedure is like this one. You see, multiply filter value, which is 3 by 3. So move first filter right away on one at a time. So start from this one, 1, 2, 3, and 1, 2, 3. Next step, 1, 2, 3. So just like shift this one, move from this one and start from this one and check like every part of the image. And this is just try to help to find important parameter from the image. So filter means like that one. So this part actually just like no need of like manual, you need to only give like the filter size. The other one will be just extracted automatically by the model. So no need of just like more like concern about this one, how like this one. Just if you know about the concepts, the only thing that you need to give or you need to just check is like which filter may be like the most important to find the significant parameter from the image. So in convolutional operator parameters, there is filter size. Actually, some of the parameters that we need to adjust in this convolution will be filter size. We need to just give filter size. There is padding also, stride also, dilation and activation function, some of the parameters that we need to adjust in the convolution layer. So we need to just represent that one. For instance, the first one is filter size. So filter size means actually, as I already mentioned that one. So for instance, if you have some image here, so you need to just like the filter, maybe if we say that 3 by 3. So if we say that the filter size will be, for instance, is 3 by 3. So 3 by 3 means 1, 2, 3, and then 1, 2, 3. So first actually just like it will be focused on this one, this area. Next one, just we need to move this one, the first layers, we need to move actually this one, and next actually we need to start from, for instance, the second layers. So we need to check from, let's say for instance, first only 1, 2, 3, 1, 1, 2, 3. Then this one 3 by 3. Next, just we need to leave this one and start from this one, 1, 2, 3 again, and then 1, 2, 3 come down. And next, just like continue the next one. So by using this type of layers, actually the whole image will be detected. Then when we assign filter size, actually mostly 5 by 5, 3 by 3, just like it needs to be like the same 2D type of sizes. Large filter sizes should be avoided because actually as a learning algorithm needs to learn filter values or weights. So when we assign the filter size is large, for instance, in this case, if I just like try to, let me show you, for instance, you see here, if for instance, in this case, if I just like say that 7 by 7, maybe just like the whole image will be just only just check by one time. So assigning large filter size will be just a problem in order to capture some important parameter or information from the images. So as much as possible, it is better to just assign small filter size than the large sizes. And the other one, odd size filters are preferred than even sized filters. That means, for instance, in this case, 2 by 2 is better than, I mean, like from this one, 3 by 3 is better than 2 by 2. Just like because actually, in order to find every parameter from that one, all odd values will be better than the even sizes. This is just like because in order to find like input pixels being around on that one, it will be just most important one. It's not actually it's a must, but you can try just any sizes. But yeah, mostly actually the like odds values will be different from that one. The other one is padding. Padding means actually after applying like for instance 3x3 filters to 4x4 images, so we can get 2x2 image size of the image has gone down. So padding means actually just like if we want to keep image size the same, we can use like a padding. So padding means actually we just like we can add some white spaces between the images or around the images. We can add just like some space. So we pad input in every direction with 0 before applying the filters. If padding is 1 by 1, then we can add 1 0 in every direction. If padding is 2, then we can add 0 in every direction. So padding actually, in order to make the image into equal sizes, we can add, for instance, this is, you see the white space here in the image. So around in the image actually there is additional white spaces that we add intentionally in the image. That is just, we call it padding. So here padding 1 means because only add one circle, one pixel or one array throughout the images. That is, we call it padding of 1. So if you need like 2x2 arrays or filters, you can add also still 2 paddings around the images in order to make the image size which is equal to 2. That's, we call it padding. The other one is other parameter is stride. So stride means like how many pixels we move filter to right or down is stride. So stride 1 is move filter 1 pixel to the right or down, and stride 2 move filter 2 pixels to the right or down. So stride means actually just to determine that how much the pixel can we just move or jump, like that one. So for instance, this one, you see that 2 means just originally started from the top one, and then the next time just like jump 2 pixels and then start from that one. So that is just stride. So if just like for instance, let's say this one is 4x4. So if just like say that stride 2 originally, so in this case we can say that, so we can start from this 2x2. Next, when we start the next one filter 1 2, we need to jump this one and start from this one 2x2 from this one. So jump this one 2 means stride of 2. If we say that stride of 1, just first start from this one 2x2, and next just we can start from this one, next we start from this one, just so by jumping one value. That is just like the way of, we call it striding. This is just the way. So for instance, this is an image that application of the convolution task using like stride of 1 with 3x3 kernels. For instance, here you see that this is some of the part. Convolutional times actually 3x3 kernels. That's just applied for this one. Pixel representation, this is just the original image, and then 3x3 kernel will be applied here. So after just like calculation, actually this will be this one, like for instance it be given like this. So this one 0 times 1, this one by this one, just like when we apply the 3x3 colors. And also this, the bottom side will be just like 0.2 times 1 plus like this one. So all this will be calculated like this one. So it's given this one around 0.1 and this one is 0.4. The convolution matrix is like this one. So using this mathematical calculation, finally the decision will be made by the algorithms. So actually dilation is to have a larger respective fields or portion of the image affecting filter output. So we can make it like dilation. So if dilation is set to 2 instead of contiguous 3x3 subset of images, every will be just like start to affect the image. So dilation means, you see that here, there will be actually like make it a dilation. Here actually, yeah, you can show that like instead of like the black, we need to just dilate of 2 strides like this one. So if you just want to delete some parts actually, or move some parts, just we can apply this type of dilation in the convolutional neural network. So instead of contiguous, actually you can make it like this one, 1 and 2. In the second one, straight one, and then jump this one and continue to filter out the next one. That is, we call it dilation. So this is an example of full CNN structure for image classifications. For instance, from this one, it will show that this is a koala. So an image. So in the first, this one is now 1, 2, 3, 4, 5. 5 convolutions or 5 filters. So 5 convolution, or that, which means like 5 filters. The first filter just only filter out eye. The second filter out nose part of the koala. The third filter just filter out the ears of the koala. So this is just like the 3. The other part of the filter will be just like try to filter out hands, and the other filter is just try to filter out leg. Then in the second step, because just like in the structure of this one, so just like this is the point is around here, eye is around here, nose around here, like based on from the box we can represent that one. So when you combine this one, eye, nose and ears, when you combine this one, it gives like a head. So in the second convolution, then we have just information, detailed information, or the model can have detailed information about the koala's head here. And the hand and the leg, it gives like some information about the body. So head is around here, body is around here, which is 1, 1. So flatten means actually this one, 1 represent the head, and then 1 represent the body. Then just like the model can have full information about head and body, which means now have a full information about the whole structure of koala. And then using this flatten, the fully connected layer is try to determine that whether this image is a koala or not. That's just how the CNN structure will be work like this. The other one actually just like in the neural networks in CNN also we can use different activation functions for just like for nonlinearity or to introduce nonlinearity. So the preferred activation function, as I already mentioned in the previous video, which is real activation function, is the simplest and the fastest one. But also actually depends on the problem and the data set. Maybe you can try like different activation functions. So I will already mention about this one in the previous class. Just let's jump this one. Well, let's see, for instance, how the activation function will affect the model performance. For instance, this is a digit number 9, and then we can apply loopy filter. Loopy filter means just only filter out these parts. This part. So loopy filter 1, 1, 1, 1 minus 1, 1, 1, 1, 1. Only this part. And this is just the data. For instance, this minus 0.1110 like this one. And after applying the activation function, the number will be just changed into 0 and 1 format. So here actually it will be just like different value. But after applying the activation function, the value will be changed into 0 and 1. And also there is 0.11 and 0.3, which is just like a real activation function that only just focus on the positive values, which is like the minimum value is 0, but there is no any upper bound. So from 0, then we can just like consider positive values. So the value will be changed into 0 and then 0.111, and like that means just the negative value will be just like ignored and only focus on the positive value. That's why the activation function just try to make it or introduce nonlinearity. So this is when we filter out actually all the negative value is changed into 0 and only focus on the positive value. So just like this is an example. So filter, the output is like, for instance, here 5. So this one is actually now is only consider this part, and the filter, that means 0 times 0, 2 times 1, 1 minus 4, then just like plus 0 times 0 plus 1 times 2 plus like this one. So it gives 5 like this. So the left side of this image will be 5, and then also we can check like this part, every part will just, and then it's possible to fill out these tables. So this is actually like different channels. This is the top part, and then a 5 channel 1 output, And then channel 2 filters will be just like, for instance, filter out on this way. This is the other one, for instance, input filter with channel. Then here is 4 channel 2 output, and then the output will be 1 9, and this is also the other. So single channel to the convolution with the different parameters. Actually, this So actually, it can be possible to change also the channel sizes. So by using different filters, it can be possible to apply multiple filters result with like different channel size. The other most important parameter in the convolutional or in the CNN will be pooling layer. So just pooling layer is the way that try to perform downsampling to reduce the spatial dimensionality of the input feature maps, as I already mentioned in the previous one. Downsampling or pooling layer is just like the function is try to reduce the size of the image without changing like the origin of the image. Only the size will be reduced. So this reduced number of parameters can reduce dimension, can reduce learning time or computation time. So just that's the advantage. The other one is just like try to reduce likelihood of overfitting, just as there are less parameters. So the function is like to reduce learning time, computation time, and also reduce the dimension, reduce the overfitting problem will be the most important thing. That's just the function of pooling layer. So most popular types in max pooling is usually like 2x2 filters with stride of 2. This is most popular, but for instance, this one is the our original image. So from this image, for instance, in order to reduce into small sizes, so max pooling with 2x2 filters and straight 2. So 2x2 means just like this one's 2, 2x2, 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 which means like into 4 convolution. So straight 2 means because this one is select 2, and then just we can jump this one and again 2. And from this one actually we can jump 2 and then again this one and again this one. So that means from this one, from the first section, this color, the maximum is 6, so only we can take 6. From this one, the maximum is 8, so we can take 8. From this one, the maximum is 4, we can take 4. And from this one, the maximum is 7, we can take it 7. So just like this is the way how we can reduce the image without just affecting the original size. The most common way of this pooling layer, for instance, as shown these images, you see that this is the original image by 224 by 224, the pixel sizes, and after downsampling, the image will be just like the size it becomes already reduced by half size. So this is just the one technique that helps to reduce like the size of the images. So pooling will be applied. So this pooling, first convolution is just try to filter out the different part of the image. Then max pooling is to reduce the size. Again, we can add convolution, and then also to convolute or filter different part of the image. And then we can add also still max pooling. So this is also another example. This is the for instance, the original, the image sizes, and then by using like the maximum one, we can just try to change it into this. So from this one, from this color, from this color, from this color, it will be becomes this one. Let's say, for instance, a full information about this is the original image. Then we can apply loopy filter. So loopy filter means only just like filter out the circle part, and it looks like this one. And after applying activation functions, the negative value will be ignored or given into 0. So 0, 0, 0. Negative value is the whole is become 0. And only just like we consider into positive values because of this activation function. Real activation function only consider from starting from 0, but in the upper there is no any limitation. So just like 0, 0 0.11, 0 0.33 is possible. So after applying max pooling, maybe we can apply like 2x2 filters or any other consideration. So if we apply 2x2 filters, for instance, from this one, the maximum is 1, so we take this one. And next, just like we consider this 2x2, this one, So the maximum will be 1, like this. And next, just we need to consider like this one. From this one, the maximum is 0.33. So this will be bigger. And also here, we need to consider this one. The maximum is 0.33. So it will be become like that one. And again, this one. So from this one, the maximum is 0.33. And from this one also, it becomes 0.33. Finally, this one. So from this one, it's just 0. And then from this one, it's just 0. So after applying max pooling, actually this image size will be reduced like this one. So there are two ways of actually finding the max pooling. The first one is just only taking the maximum value like this one, from like by comparing these 4 values. Just we can just take it, the maximum one. Either we can also take by using average. For instance, from this one, 5 plus 1 plus 8 plus 2 and divide by 4, and it becomes 4. And then 3 plus 4 plus 9 plus 2 divided by 4, which is the total number, is 4.5. So we can use either average way or just the maximum way to calculate the pooling values in the convolution layers. The last layer in CNN is, we call it fully connected layers. So fully connected layers, which is the last layer in CNN. This layer, it connects all nodes from the previous layers to fully connected the layers, which is responsible for classification of the image or detection of the image like this. For instance, this one, the full structure. So the first one is the image, input image here. There is convolution. So this convolution, actually different convolution part is a filter, try to convolute or filter out different part of the image. And pooling, just reduce the size. Finally, there is fully connected layers, that's one. So all this one is changed into the flattened layers. And the fully connected layer just try to categorize, for instance, whether this image will be 0 or 9, or from 0 to 9, just like the output layer, or the classification detection part will be done from the fully connected layers. So typical CNN has several convolution plus pooling layers, so it's responsible for feature extraction at different level of abstraction. So just this is some explanation about example of CNN, but so CNN is not only do classification, but also it can be do a feature extraction, plus also detect paths that try to detect like shapes, images, and lines. So this one. So this let's see that some sample CNN codes that show that the implementation. So let's see how each layer, for instance, input one. So here model 1 dot add convolution 2D, because like it's the image, the data is image, and you see that 25 3 3 3. So this one, actually the number of the convolution is 25 and the filter is 3 by 3 filter. So this is, it shows that 3 by 3 filters, and there are totally 25 3 by 3 filter, which means like 25 total different part about the image. And the input of the shape is 20 by 28, and then just 1. This one indicated that the image is grayscale, so it's not colored image, just a black and white image. 28 it just showed that the shape of the image. So convolution means like this one, convolution 2D. So this one will be done like this one. Input shape 28, 28 and 1. So 28 by 20 pixels, and 1 is black and white. But if just like it's RGB, we can say that 3. Next, we can just do the max pooling. So max pooling model 1 2 like this one. Add max pooling 2D, and then we can add 2 by 2. So just like this will be just like by using 2 do, for instance, 2 by 2, 1 2 1 2. So the maximum one will be 3. So by using like this one, the model can try to just reduce the size of the image by using max pooling. So you can add like the pooling like 2 by 2, 3 by 3, and like that one, and it will be just try to reduce the image size. So here convolution is done here, and again max pooling here, and then again we can do convolution Then now we can try to convolute the image into 50 different convolutions by using 3 by 3 filters. So it will becomes like 50, like a new parameter is just, and again we can add also max pooling here. So this is just the way or the procedure that we try to convolute or reduce the size of the image. This one also the same procedure. Then finally, actually the fully connected layer. So there is convolution is done, max pooling is done, convolution is done, and max pooling is finally. Here actually the flatten is done like model 2 dot add flatten. So flatten is this image will be changed into like in terms of numbers, like by checking every possibilities, and then this one actually just like similar with like the output layers, like in neural network, and like that one at the end of that one, just this is the model now. We can add a dense output dimension will be done. Activation function is done, and then also we can put the output dimension here. This output dimension 10 means that it showed that the total just like the class will be just like, for instance, here is like from 10 classes. And the output activation function becomes softmax. So this fully connected layer that helps us to classify or detect the image. For instance, this one actually Kaggle. In Kaggle, this is a sample data sets that show that with like different animals and try to just actually classify dog or cat, so for classification of images. So there is a data set which is 2000 cat and 2000 dog images, and then the model will be try to classify on this one. So maybe I think you can just try it from this one. When we try to see some CNN applications, application of convolutional neural network, for instance, here an image-based data for in optical communication networks. For instance, here a data set that shows the different images from this one. So by using convolutional neural networks, we can try to use CNN for channel estimation, mode demodulation, optical signal analysis, impairment diagnosis, optical performance monitor, or digital signal processing, spectral analysis, or for the other functions. So if you have just like a data set, which is image-based data set, then by using convolutional neural networks, maybe you can try to do a different, or you can try to solve different problems. Just this is the one application. The other one is actually just like for classification, for retrieval, for image classification, retrieval, and the image detection will be also the other. Detection, segmentation, like shown here, actually just detect different objects from this one, and or segment only the objects from this one. It's also the other parameters that we try to focus on this one. And here the other one just try to show like, for instance, raw applications, style transfer, just translate or transfer images from one image into the other one, actually just like, for instance, original image is this one and translate into or transfer into this style. I think maybe it's not. So as I already mentioned in the neural network, so this underfitting and overfitting problems also happen in CNN. So we need to consider this one. I already mentioned this one. For instance, this is just a structure that shows that the model is not learning enough. So in that case, we call it underfitting. And this one is ideal fit or the best fit, maybe just like, because this is a graph that shows that the validation error. This is a training error. So maybe around here we call it a good fit or a good fit or ideal fit, this one. And this maybe show that overfitting because the gap between validation and testing error is high. So the model is learning by heart, which is like only try to memorize the training data, but forget about testing data. So because of that, it happens overfitting. So this problem will be happen. So you need to just like I already mentioned in the previous video, you can try to use like by tuning different parameters, by applying regularization or by applying dropout, or just like by applying like different cross validations, you can try to minimize overfitting problems. Mostly actually in CNN, that it happened the problem of CNN. I mean like overfitting. Underfitting, maybe it just happens if the iteration or the number of the epoch is too small, maybe underfitting will be happen. Like for instance, if we make it the epoch only 5, because there is no enough time to iterate to learn the parameter, the data. At that time, maybe it will be happen the underfitting problems. But sometimes overfitting may be happen in CNN if the data set is not enough. Like maybe if we have just only 50 sample of training data, maybe that's just not enough to train CNN. So during that time, overfitting will be happen. So increasing the data size is also the one solution to reduce overfitting problem. Let's so some sample tutorial about actually this is CNN in Python with Keras. Some tutorial about CNN in Python. So actually this is a tutorial or a link that shows that about this one maybe. So actually this is some important information about CNN. So if you need to learn in detail about this one, maybe you can see convolutional neural networks, which is a data camp that discuss about in detail about the CNN, about so you can see, you can read this information, so maybe you can deeply understand about the structure about CNN. So there is a link from this the data camp that talks about convolutional networks with TensorFlow tutorial that shows that in detail. So maybe you can try to refer this one about the CNN or convolutional neural network. So just consider like this one. Also convolutional network in Python with Keras, like here also, almost with different data sizes, and also there are practices about this one. So you can see in detail about the practice. So you can read this one because actually our time we cannot go in detail about that one, but just the procedure is about that one. For instance, the procedure like in this case is for training that start from the data. So first we need to have a data set, so load a data set. So for instance, this one is a fashion minutes data set will be loaded from online. So just the data set is loaded here as shown here. You see here. So for instance, this one is actually there is a fashion minutes data set. So this data set will be just available online, and the data is loaded like this one. Then next to that one, actually just try to analyze the data set from this one. For instance, training data set will be just train X and train Y, and testing data set is test X and test Y, which just split it into two. So the total type number of training data set will be around 16,000, and testing data is around 10,000. So the shape of the image is 20 by 28 because it's the image, two-dimensional images, so 28 by 28. Just like from this one, try to total number of output will be just 10. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 different classes, which is the total number of the class will be 10. This is the code will be just like defined here. And this is just try to figure out about like plotting. So to plot, like this is the library to plot or to show about or to display about the figures. For instance, here this is some of the graph or the images from the fashion that shows a different image. And then data pre-processing. This is a way of just shaping the images. So train x dot reshape, just the shape will be just like this is the dimension, and make it reshaping data. Then just like also data pre-process that try to change the data, or just we can do type data normalization. The data will be changed into 0 and 1 or in the pixel formats. It will be done. Then after that one, actually just we can try to make or train or develop CNN models like this one. So shaping is done. So the network will be, the convolution will be done like this one. This is the structure. So the image will be done here. So first convolution will be done by using 3 by 3 filters. So total of we have 32 convolutions. And then pooling will be done by using 2 by 2 filters. And again convolution. Total of we have 64 convolutions by using 3 by 3 filter like this. This is just a sample. So like this is some of the library that's imported in the Python. Keras, sequential input model, dense, dropout, flatten, convolution, max pooling. So this is a library. So this is convolution. For this one is for max pooling. So you need to import this type of libraries. So this is a parameter that, for instance, assigned batch size is 64, epoch is 20, number of classes 10, some of the parameter. So this is the neural network model you see here. So it started from the model name is fashion model and sequential. Fashion model add convolution of 2D because the image is 2D. So total convolution is 32. Kernel size or filter is 3 by 3. And the activation is like linear type. And the image shape will be 28 by 28 and 1, which is like black and white image. And this is activation function, leaky relay, so max pooling is applied, and again convolution, activation, max pooling like this. And finally, this is called the fully connected layer start from this one. Try to change into flatten and dense layers, which is like the connection and the activation function. Finally, this is we call it the output layer will be determined by using softmax. So this is just a structure. Just once you understand about actually the convolutional neural network, then after that, even if the data will be changed, it is easy to customize. Only you need to modify some part of the code. So I think if you try to understand the code or which part like can done, or if you identify that, for instance, the functionality of each line of the code is maybe easy to modify or customize when you change even the data set. So maybe also you can use this data set as a sample and you can just try to modify and customize into according to your data set. Is maybe it's not difficult, so just try to read this as a reference. Also you can go in Kaggle, and then you can just access, like for instance from the Kaggle there are different sources that talks about CNN, and then you can just get some further information about the CNN. Okay, so this is some of the reference that I use or adopted slide from this one, especially thanks for Professor Lee. That's just I use some PowerPoints from this one, and the other sources that I just try to use slide from this one. So I try to also you can just see these sources in order to understand more about CNN. So just let's stop about CNN here, and you can read more about to understand about CNN. Either if you still have some questions, just you can contact me by using a line or email address, and then just I can try to help you to give you more information about CNN. But just like for today, let's stop about CNN here. Thank you very much.